Client in Jakarta Enterprise Beans, EJB. Now we are focusing on EJB client. When one enterprise bean, call it the source enterprise bean, accesses another enterprise bean, call it the target enterprise bean, the source enterprise bean is the client of the target enterprise bean. If you are using EJB 3.0 with annotations and dependency injection, OC4J initializes the instance variable that corresponds to the target reference. If you are using EJB 2.1, you must use JNDI lookup in this scenario. Here you can see the composition of an EJB home proxy in JBoss. Let's begin our tour of the EJB container by looking at the client view of an EJB through the home and remote proxies. It is the responsibility of the container provider to generate the javax.ejb.ejb home and javax.ejb.ejb object for an EJB implementation. A client never references an EJB bean instance directly, rather it references EJB home which implements the bean home interface and EJB object. Which implements the bean remote interface. This figure shows the composition of EJB home proxy and its relationship to the EJB deployment. Here you can see the EJB developer, EJB deployer, org.jboss.ejb.ejb deployer is invoked to deploy an EJB jar. An EJB module org.jboss.ejb.ejb module is created to encapsulate the deployment metadata. The create pace of EJB module lifecycle creates an EJB proxy factory org.jboss.ejb.ejb proxy factory that manages the creation of EJB home and remote interface proxies based on the EJB module invoker proxy binding metadata. There can be multiple proxy factories associated with an EJB, and we will look at this more closely shortly. The proxy factory construct the logical proxies and bind the home into JNDI. A logical proxy is composed of a dynamic proxy, java.lang.reflect.proxy, and the home interface of the EJB that proxy exposes, the proxy handler, java.lang.reflect.invocation handler, implementation in the form of client container, org.jboss.proxy.client container, and the client side interceptors. The proxy created by the EJB proxy factory is a standard proxy. It is a serializable object that proxies the EJB home and remote interfaces as defined in the EJB module metadata. The proxy translates the request made through the strongly typed EJB interface into the D-type invocation using client container handler associated with the proxy. The dynamic proxy instance is bound into JNDI as the EJB home interface that clients look up. When a client does the lookup of a EJB home, the home proxy is transported into the client VM along with the client container and its interceptors. Using dynamic proxies, avoid the EJB specific compilation step required by many other EJB containers. The EJB home interface is declared in the EJB-jar.xml descriptor and is available from the EJB module metadata. A key property of dynamic proxies is that they implement the interfaces that expose. This is true in the sense of Java's strong typing system. A proxy can be cast to any of the home interfaces. The reflection on the proxy provides a full details of the interfaces it proxies. A proxy delegates calls made through any of its interfaces to the client container handler. A single method required of the handler is public object invoke, object proxy, method dem, object array args, throws a throwable. The EJB proxy factory create client container and assign this as a proxy handler. The client container state consists of an invocation context org.jboss.invocation.invocation context and chain of interceptors org.jboss.proxy.interceptor. The invocation context contains following: the JMX object name of the EJB container, M being that the proxy is associated with, the JavaX EJB metadata for the EJB, the JNDI name of the EJB home interface, the transport specific invoker org.jboss.invocation.invoker. Interception chain consists of the functional units that make up the EJB home and remote interface behavior. This is a configurable aspect of an EJB. An interceptor makes and the interceptor makeup is contained in the EJB module metadata. Interceptors org.jboss.proxy.interceptor handle the different EJB types, security, transactions, and transport. You can add your own interceptors as well. The transport specific invoker associated with the proxy has an association to the server side detached invoker that handles the transport details of the EJB method invocation. Detailed the detached invoker is a JBoss server-side component. You configure the client-side interceptors by using jboss.xml client interceptors element. When the client container invoke method is called, it creates an untyped invocation org.jboss.invocation to encapsulate request. This is then passed to the interceptor chain. The last interceptor in the chain is the transport handler that knows how to send the request to the server and obtain reply, taking care of the transport specific details. Here you can see EJB deployer is connected to EJB module, and EJB module is connected to proxy factory. Proxy factory is connected to proxy. Proxy and client containers are inside logical EJB proxy. Proxy interacts with EJB home. Proxy interacts with client container. Client container interacts with JBoss server. You can, as an example, you can see a client application. Here invoking EJB method, if you consider that part. Once you have the home interface, for the bean, you can invoke one of the beans create methods to instantiate a bean. Here, for example, then you can invoke EJB's methods in the normal way. Here you can see localhost :2481 :OCRL here. Here, for example, we can employee number is here for example, for Alan, for instance. And here you can see the lookup bean, and here create a bean instance, and create a slot for the incoming data. And get the data and print it here. As an example too, you can see an example of EJB client code. This shows the source code for the sample EJB client application that is part of the VSE connector client. The code is based upon the use of the WebSphere application server as the web application server type. Here define properties specifying IIOP : // as the provider URL causes the EJB client to search for a name server on the localhost listening on the port number 900, which is the default for the WebSphere application server. In real environment, you would specify the complete URL such as IIOP : // bank server .mybank.com 9019. Here you can see the initial context object is instantiated. Here the home interface of the employer bean is looked up. The string used here to identify the EJB is stored in the EJB's deployment descriptor. You can view the EJB's deployment properties by using WebSphere Administrative Console. Here you can see create a remote interface object to obtain access to the EJB's business logic methods. This call to the remote interface create method invokes the EJB create method of the EJB. Here access the EJB's business logic methods. For example, get some properties of employer 103, employer that has the number 1003. Please be aware, however, that the EJB is always accessed via the remote object. In this example, employer.class in this example, employee number and password are taken from the EJB sample provided with the VSC connector client, which also provide the utilities to fill the sample VSAM cluster with some simple sample data. In this code, you can see an example that configures the EJB client connections, global interceptors, and invocation timeouts using the EJB client element in the wildfly-config .xml file. You can use the EJB client element, which is in the URN colon wildfly client EJB colon 3.0 namespace. To configure EJB client connectors, EJB client connections, global interceptors, and invocation timeouts using the wildfly-config.xml file. Invocation timeout. This optional element specifies the EJB invocation timeout. It has seconds attribute. The timeout in seconds for EJB handshake or the method invocation request response cycle. This attribute is required if the execution of a method takes longer than the timeout period. The invocation throws java.util.concurrent.timeout exception However, the server side will not be interrupted. Global dash interceptors. This optional element specifies the global EJB client interceptors. It can contain any number of interceptor elements. Interceptor. This element is used to specify an EJB client interceptor. It has class and module attributes. Class attributes: the name of a class that implements org.jboss.ejb.client.ejb client interceptor interface. This attribute is required. Module attribute: the name of the module that should be used to load the interceptor class. This attribute is optional. Connections. This element is used to specify EJB client connections. It can contain any number of connection elements. Connection. This element is used to specify an EJB client connection. It can optionally contain interceptors element. It has a URI attribute. URI attribute: the destination URI for the connection. This attribute is required. Here we are considering a session being exposing multiple client views in access in the global JNDI namespace. If a shared bean is packaged in shared.jar without a deployment descriptor, deployed as a standalone module, the resulting global JNDI names entries are here. Now we are considering client view of a message-driven bean in message-driven bean component. For example, the reference to the queue for Jakarta messaging message-driven bean might be injected as follows here. Alternatively, the queue for stock info Jakarta messaging message-driven bean might be located using following code segment here. Now we are considering client managed demarcation in sample scenarios in support for transactions. A Java client can use Jakarta.transaction user transaction interface to explicitly demarcate transaction boundaries. Client program obtains the Jakarta.transaction.user transaction interface through dependency injection or lookup in the beans EJB context or in the JNDI namespace. Now we are considering the client view of exceptions in exceptions handling. A client accesses an enterprise bean either through the methods of business interface typically do not throw the java.rmi.remote exception regardless of whether the interface is a remote or local interface. A client accesses an enterprise bean either through the enterprise bean's business interface, whether local or remote, through the enterprise bean's no interface view, through the enterprise bean's remote home and remote component interfaces, through the enterprise bean's local home and local component interfaces, or through the enterprise bean's web service client view, depending on whether the client is written to the enterprise bean's 3.x API or earlier API, and whether the client is a remote client, a local client, or a web service client. The methods of the business interface typically do not throw the java.rmi.remote exception, regardless of whether the interface is a remote or local interface. The remote home interface and the remote component interface are Java RMI interfaces, and therefore the throws clauses, all their methods, including those inherited from super interfaces, include the mandatory java.rmi.remote exception. The throws clause may include an arbitrary number of application exceptions. The local home and local component interfaces are both Java local interfaces, and the throws clause, all their methods, including those inherited from super interfaces, must not include the java.rmi.remote exception. The throws clauses may include an arbitrary number of application exceptions. The no interface view is a local view, and the throws clauses of all methods must not include the java.rmi.remote exception. The throws clauses may include an arbitrary number of application exceptions. Now we are considering enterprise beans client's responsibilities in security management. These rules are here. Here we are considering we are defining the rules and that enterprise beans client program must follow to ensure that the security context passed on the client calls and the possibly imported by the enterprise bean do not conflict with the enterprise bean's server capabilities for association between the security context and transactions. The rules are a transaction client cannot change its principal association within a transaction. This rule ensures that all calls from the client within a transaction are performed with the same security context. A session beans client must not change its principal association for the duration of the communication with the session object. This rule ensures that the server can associate a security identity with the session instance at instance creation time and never have to change the security association during the session instance lifetime. If transactional requests within a single transaction arrive from multiple clients, this could happen if there are intermediary objects or programs in the transaction call chain. All requests within the same transaction must be associated with the same security context. Now we are considering clients written to the enterprise bean 2.x APIs in interoperability of enterprise beans 3.2 and earlier components in compatibility and migration. An enterprise beans that is written to the enterprise beans 2.1 or earlier API release may be a client of components written to the enterprise beans 3.x API using the earlier enterprise beans APIs when deployed in an enterprise beans 3.x container. Such an enterprise beans 2.1 or earlier client component does not need to be rewritten or recompiled to be a client of a component written to the enterprise bean 3.x API. Such clients may access component written to the enterprise bean 3.x APIs and component written to the earlier enterprise beans API within the same transactions. Now we are considering clients written to the enterprise bean 3.x API. A client written to the enterprise bean 3.x API may be a client of a component written to the enterprise bean 2.1 or earlier API. Such clients may access component written to the enterprise bean 3.x APIs and components written to the enterprise beans APIs within the same transaction. Such client access component written to the earlier enterprise beans APIs using the enterprise bean 3.1 client view home and component interfaces. The EJB annotation or the EJB ref and EJB local ref deployment script elements may be used to specify the injection of home interfaces into components that are client of beans written to the enterprise beans client view. Now we are considering client programmers' responsibilities and responsibilities of enterprise bean roles. The enterprise beans client programmer writes applications that access enterprise beans via their business interfaces, via their no interface view, via their web service client view, or via messages, or view their home and component interfaces. Example, we can consider no class def found exception, no class def found exception, class not found exception. If the client issues either of these, there is probably something missing or corrupt on your client side class path. The exception should give you a good indication of which class is missing, and from this you may be able to work out which jar file to add to the class path. Remember that you need j2ee.jar and the fully deployed jar in the class path. It is unlikely that CICS will issue any useful additional information for these problems. No class found error javax/EJB/home handle. This indicate that a client application does not have EJB 1.1 level classes available on the class path. Ensure that j2ee.jar is available. These things are under CICS transaction server for Z/OS. And then as an error example, we can consider getting EJB client 000025 error if a EJB is called on a remote JBoss EAP server. Here you can see the error java.lang.illegal state exception, EJB client 000025, no EJB receiver available for handling, app name : remote test remote, module name : EJB, distinct name, and combination for invocation context, etc. Now this is the end of my presentation. Thank you very much for watching it.